Okay, this is the video for lesson 1-7 on functions. The first part of these notes we have already done in class. You should have this filled in, but if for whatever reason you didn't have your notes with you in class today and didn't write this down on paper, I would take that opportunity to get these down right now. Okay, just a reminder, what is a function? Okay, it means that we have one x value paired with one y value. Okay, and these are examples of functions right here, 4 different ways that we can write the same thing. And the key thing that you're looking for is that none of the x values repeat in order for it to be a function. Alright, these here are examples of relations that are not functions, okay? We have a 4 repeating in the domain, in the x values. There's two 4s in the table, okay? The 4 has 2 arrows coming out of it. These are not functions. Okay, and we also talked about the vertical line test today, which means that if I have a graph and I draw a straight up and down vertical line, if it's a function, it will only touch that graph in one place. So this is a function. This one is not, because my vertical line touches the graph here and there. 2 places, not a function. All review from what we did in class today. So the next thing we need to talk about is function notation. Okay? You have seen equations like this, where we have y equals and then some expression over here that y is equal to. Right? What we're going to talk about today is something called function notation. And it's just a different way of writing out functions. And we use this here, this f parentheses x. Now, what's important to note here, this does not mean f times x. We read this as f of x. So y is a function of x, and here is the function itself. Okay? So what you have to remember is f of x is the same thing as y. When you see those, they're interchangeable. They mean the same thing. Okay, and in a function, x represents the input, or the x-coordinate, y represents the output, and because y and f of x mean the same thing, f of x is also the output. So this problem here, evaluate the functions listed below, and they give us this function, f of x is equal to 2x minus 3, and then state the domain and range. Okay, the first thing they tell us is to find f of 1. Okay, in function notation we write f of x. So what do you notice between these two? Where we had an x here, it's now been replaced with a 1, which means that in our function f of x equals 2x minus 3, everywhere that there's an x, we're going to replace it with a 1. So our function becomes 2 times 1 minus 3, multiplication first, 2 minus 3 equals negative 1. So f of 1 is equal to negative 1. Then we're also asked to state the domain and the range. Alright, so for domain is x values. How many x values do we have for this problem? Well, just 1. We were just supposed to find f of 1. So our domain is just 1. And we're going to use these little brackets to indicate that this is a set of numbers. The domain is a set of numbers, and 1 is the number in our set here this time. We're also going to list the range. Domain is x values, so range has to be y values. Alright, and when we plugged 1 into our equation, we got negative 1 as our output. So the range, and my brackets are terrible, don't make fun of me. The only element in our range for this problem is negative 1. Part B, same thing written in a different way. Now they're telling us x is equal to negative 3. We're still using the same equation, 2x minus 3. And everywhere we see an x, we're going to replace it with a negative 3. So we have 2 times negative 3 minus 3. Multiplication first, negative 6 minus 3 is going to be equal to negative 9. We also need to list domain and range again. Domain is x values. The x value they gave us for this problem is -3. And the corresponding element in the range, the number that we got when we put -3 into our equation, is -9. I'm going to leave problem C and D for you guys to do. Okay, do it on your own. We're going to skip to number 2. Find the range of f of x is equal to 2x minus 3 given the domain -2, -1, 0, 1. Okay, if they give us a domain, remember these are x values. So we're going to take each of these numbers, plug them in for x in our function, and figure out the corresponding y values, which will give us our range. So first we would have to do f of -2. So I have 2 times -2 minus 3. We would also have to do f of -1, f of 0, and f of +1. Alright, so pause that video, go through and work out all of those problems. Okay, so here's what you should have got by plugging in these numbers. Okay, working out the expression, you should have got f of -2 is -7, f of -1 is -5, f of 0 is -3, and f of 1 is -1. Alright, so given these numbers for our domain, these are the corresponding numbers that we get for the range. And again, it's a set of numbers, so we need to put them in brackets. Alright, so part of the reason that we do this whole thing is so that we can use algebra in real life. Okay, so we're going to write function rules to describe real-world situations. Okay, this one says Christina earns $7.50 an hour babysitting. Write an algebraic expression to represent the money Christina will earn if she works 8 hours. Okay, so we don't know how many hours that she works, but I know that for every hour she works, she's going to get paid $7.50. So to figure out how much money she earns, I'm going to multiply 7.5 times the number of hours that she works. Okay, then you have a table down here to fill out. Choose 5 values for the number of hours Christina can babysit and create a table. You can choose any numbers you want. But since this is a real world problem, you need to think about that for a second. Is she going to work negative hours? It's not possible, those don't exist, so I wouldn't pick negative numbers. And Christina might love babysitting, but I don't think she's going to babysit for 200, 300, 400 hours. So pick numbers that would be realistic. I'm going to choose to use 0, 1, 2, 3, and 4. Okay, so you pick the numbers you want, and then you need to plug them into our equation, and we chose values for the number of hours. So these numbers will be plugged into H to figure out how much money Christina will earn if she works that number of hours. I picked 0, 1, 2, 3, 4, and then these are the Y values that I got by plugging them into my equation. Use the values in your table to create a graph. Right, so you need to put a scale on the coordinate plane that was given to you. Alright, think about what would make sense. Every mark does not have to be $1. Think about what makes sense for the numbers that you chose. For the numbers that I picked, my graph will look like that. 0 hours, $0, 1 hour, $7.50, 2 hours, $15, and so on. Problem number 2. It costs 25 cents to send a cell phone picture. This problem was obviously written back in the day when people did not have unlimited messaging. Okay? So we have to write a rule to figure out how much it's going to cost if I send P pictures. Okay, again, it's going to be the number of pictures times 25 cents because that's how much it cost. So C, the cost, is equal to 25 cents times P, the number of pictures that we send. Okay, now you need to create a table and a graph again. Make sure that you are choosing numbers that make sense for this problem. Go ahead and pause the video and get your answers, and then when you come back you'll be able to check them. Okay, so we're back. Again, you could have chosen any numbers that you wanted to as long as they were realistic. I went with 0, 1, 2, 3, 4 again. Plugged them into our equation C equals 0.25p. And this is the resulting table and graph. Okay, that's it for functions today. Alright, bring these with you next class. We will finish up and review and then test on Thursday. See you guys soon.